we would have 35 over 159, and our answer would be 0.22, exactly. And then in part C, it asks us, well, what if we had the college from part A or the NFL from part B? So we can just take those and add them together. So that 0.62 plus 0.22, and we get 0.84. And then part D says, if we know the probability of students wearing another sports shirt is 0.05, how many students does that represent? Okay, so to solve that, right, I did one of these in class, and we're looking for the x, and we have the total, the 159 equal to the 0.05. So we can just multiply these together. Now when we multiply them, we don't get a nice round number, right? What do we get? 7.95. So there it's like, well, is 7 a better answer or is 8? Sometimes it's hard to tell because that really isn't saying 8 people, right? But a good way to figure that out, how could I check and see if 7 would work better or 8? Did anybody do that? What'd you say?
All the totals together and see which one would be better.
So how did you do that? Or did you do that? Okay. Yeah.
Do 7 divided by 159 and 8 divided by 159 and see which one's closer to 0.05.
Great. So if you put 7 or put 8 in here, see which one ends up being closer. Did you do that? Yeah, so what did you come up with? 8. So definitely 8 is closer. When you do that, it seems closer to the actual probability that we're interested in. So we would probably go with 8 in that case. If they were about the same on either side, then we could kind of go just to go to 7 because it would probably be clear. But here it definitely looks like 8 makes a little bit more sense. The last one, if there's 40,000 people who attend your school, estimate the total number of people who would be wearing a college football shirt. Probably the easiest way to approach this is just think about, okay, we're changing this total to 40,000, and we want to find x, and we already know the probability over here from part A. So we would have that 0.62 times 40,000. That's the easiest way to get it. So when you do that, you actually do end up with a round number, 24,800 is what I came up with for that one. Yeah?
I set up like a proportion and I just kind of cross multiplied. And I got 24,654. Is that wrong? Like if I show my work?
So you went back and used kind of the original probability calculation without rounding it off. So that's okay. Yeah. So you just didn't use the rounded value there. Yeah.
How did we get D?
D. So you're taking, so that's what's up here. You're taking 0.05 times 159.
Oh, okay.
Yep. To solve for x, the number of people. All right. So for question 2, the first one says, was random selection used and why or why not? So who wants to try that one? Yeah, go ahead.
I said yes because they used a random number generator.
Okay, so they used a random number generator, and you want to think about, were they selecting from their population of interest? So were they? Yes, right? So if their population of interest was those students before their junior year, and then they were selecting from the freshmen and sophomores, yes. So they were using that random number generator to select from the population of interest. Yep. What about the next one? So random assignment, why or why not?
It's both.
Both?
Both random assignment and not random assignment because random
No, that's not a choice. Go ahead.
Random assignment would be okay for it because last names don't really, it's not really in a specific order per person, but it also leads to because some of the people might have similar ideas if they're in a family.
So if you're saying, so what you want to think about is, would all the people have an equal chance of being in either group if we did that? No, right? So based on the fact that you're saying, oh, this wouldn't always work. It wouldn't always be random. That means it's not random. Sometimes times you might end up with groups that are kind of equally divided, and they give you, right, but that method would not be considered random assignment. So it is kind of tricky. I can see how you were thinking, both there. But we always want to go with, what would be the better answer? And so if we're saying that, this is not a random method where everyone would have an equal chance of being in each group, then it would not truly be random assignment. Does that make sense? Okay, cool. Who can tell me the control and experimental groups?
Control group is like the group that went to the meetings, which is campus issues,
Mm-hmm.
and then the experimental group is the group that went to meetings with career counseling.
Great. Yep. So the control would be the campus issues group, and the experimental would be that career center group. So they're having something different. That experimental group we're interested in if that is making a change, right? Who can give me a beautiful, fabulous null hypothesis? Doesn't have to be really beautiful or fabulous, I guess. I mean, but just a good one. How about that? Yeah.
Attending weekly hour-long meetings discussing opportunities for employment and graduate school programs will not increase student interest in pursuing internships and research opportunities.
Okay, so you kind of did that, the one-tailed one there, like we talked about before class. So you're saying it would not increase there.
So should we say not make it?
And that's okay to do that now, right? But you also, so the one part you want to leave off, you left off, is compared to who, right? So you said attending these groups that did this and this won't increase it, and then you want to say compared to that other group too, right? So for instance, just for a two-tailed one, you can say there's no difference in scores on the CFC test on average in the groups represented by the campus issues compared to the career center group, right? So there I'm saying no difference, just two tails for now. Between these two groups, so mentioning the two groups, and then also on that measure of your dependent variable. Questions? Yeah, so you can have it one-tailed if you want. That part was okay. You just want to make sure that you mention both of those groups. And then for the research hypothesis, it would be the same thing, but if you're leaving it two-tailed, then you would just be saying there is a difference. Okay, so if the mean scores for the experimental group and the control group are almost identical, the researcher should decide to what? Yeah. Fail to reject the null, right? We're saying there doesn't seem to be a difference based on our sample. What would a type 1 error look like? Yeah.
Students who went to the meetings that offered discussions about employment for graduate schools were more interested in pursuing internships or research opportunities before they were here.
Okay, so you're kind of only saying, I think, one part of it. So when we talk about errors, you want to say, what we concluded from our test, and then say that that's different from what's happening in reality. So you kind of were just giving the one part of it. So concluding that the Career Center group had higher scores, that the method was effective, right, based on our test, but in reality it's not. That would be type 1, saying, there's a difference, right, kind of false alarm, we're getting excited, this works, we should implement this program, but really it's not making a difference at all. And then type 2 would be the opposite, saying, our test is showing this program doesn't really do anything, these career center talks don't make a difference, but in reality they actually do. So you need those two parts. So what we're concluding based on our test, and then kind of the oral question. Based on our answer to part E, which error could be possible? You can tell me. Yeah.
Type 2 error,
Type 2, why?
because it says that, indeed, it says that if the CFC scores were almost identical, then the researcher fail to reject the null, and then a type 2 would be if they had failed to reject the null, but in actuality it was false.
Right, yeah, so because part E is saying fail to reject, that's the first part of a type 2, right? You would have to say, oh, our test told us there was a difference, fail to reject,